Howdy, howdy, howdy. I'm recording this video and you guys are sitting patiently working right now. I appreciate it, guys. How you doing, guys?
Good!
Awesome. Then be quiet now. Just kidding, but kind of not. Be quiet. All right. Anyway, I'll try and make this quick and painless. So answer key for our textbook questions. Question number 2. Look at the design on the right. Beautiful. Write 2 part-to-part ratios. Well, I notice I've got 2 yellow hexagons, 1, 2, 3, 4, 5 triangles. Okay. I can also switch the order around. So I've got hexagons here. I've got triangles there. Okay. So again, I can switch these around. So instead of it being hexagons compared to triangles, I can flip it. Triangles to hexagons. Boom. So there are your 2 part-to-part ratios. Now we can go part to whole. So if I'm going hexagons to whole, I've got 2 to how many total? Well, 1, 2, 3, 4, 5, 6, 7. 2 to 7. I can also go 5 to 7 if I'm comparing triangles to whole. Boom. Question 2, done. Question 3, write at least 3 ratios for each model. Identify the ratios as part to part or part to whole. Okay, so for A, I'm going to label my work because it's definitely labeling my work. Let's go part to whole first. I've got 3 squares to 4 shapes total. Then I'll go 1 circle to 4 shapes total. These, of course, are part to whole. And then I'll do 1 more. I'll go squares to triangles. So we've got 3 squares to 1 circle. No triangles. We got 1 circle. Okay, and that's part to part. Cool. Sweet. Now I'll go to B. I'll do the exact same thing. I'll do a couple part to wholes. So I've got 3 yellow moons or crescents to 5 total. I've got 2 of the green ones to 5 total. These are part to whole. And then I'll go 3 yellows to 2 greens, and that's part to part. Boom. Question 3 is done. Crush it. Question 4. Use counters to model each part-to-part ratio. Sketch each model. So for A, I've got 4 to 3. I'll just write it down just to help my brain. 4 to 3. So we want part-to-part. All right. Well, I'm going to use 1, 2, 3, 4 circles, and then I'll do 3 triangles. Cool. Part-to-part. 4 to 3. B, same idea. I'll do circles and triangles again. So 1 circle. 3 triangles, not 3, 7 triangles. Boom, done. C, we got 3 to 5. I'll do X's and O's. 3 X's. 5 circles. Yep. Ooh, that's 4. Yeah, that's supposed to be 3 to 5. So there we go. Should look like that. And D, we got 6 to 8. I'll do dots. 1, 2, 3, 4 dots. 2, 6 circles. Again, whatever you choose to draw as a shape doesn't matter. As long as your ratio is good. Because we've got 6 to 4. Cool. Awesome. Moving on. Question 4. Use counters to model each part-to-part row. I already did that. Okay, so we're skipping question 5. We're going to skip right ahead to question 6. So Tara is mixing lemonade from concentrate. She adds 4 cans of water to each can of concentrate. So that's kind of a tricky question. Let's underline something that's important. She's mixing lemonade from concentrate. She adds 4 cans of water to each can of concentrate. So each can of concentrate, how many is that? That's just 1. So let's make a ratio right now. Let's go W for water and C for concentrate. We said that there's 4 cans of water for each can of concentrate. So that's 4 to 1. So for every 1 concentrate, we're putting in 4 water. So A, write a ratio to compare the amount of concentrate to the amount of water. Well, I did that backwards, so I'll do it properly. So it's going to be 1 to 4. There we go. That's A. Question A, 1 to 4. B, now it says model the ratio using counters. Sketch your model. Okay, so I'll do a square for the concentrate, I'll do triangles for the water. Boom, there it is sketched. C. If Terry uses only 1 can of concentrate, how many cans of lemonade will the container need to hold? So what this question is essentially asking is if we're putting in 1 can of concentrate, how many cans of stuff total? Well, we have to remember, for every can of concentrate, we're also throwing in 4 water. So 4 waters and 1 concentrate together, that's how much? That's 5 together. So the answer is 5 cans total. Okay. Kind of a weirdly worded question. D. What fraction describes the part of lemonade that is water? Well, we know there's 5 parts total. That's our denominator. Okay, and how much of that 5 is water? Of course, it's 4, right? Because we had 1 to 4. Both of those together equal 5 total. 4 parts out of those 5 are made up of water. And E, last question. What other ratios can be used to describe the lemonade? Well, we know we have 1 to 4. That's part to part, right? Concentrate to water. We can go backwards. We can go water to concentrate. We can do a part to whole, like we already have been. We can go 1 part concentrate to 5 cans total. We can do 4 cans of water to 5 cans total. And of course, we could flip those around as well, right? We could also have 5 to 1 and 5 to 4. Cool. Those are all the possible outcomes, or rather, all the possible ratios. Now, what question are we supposed to go on first? I think we're supposed to skip one here. Yep, we're skipping to 8. Cool. You don't want to do questions you're not supposed to. That's a waste of your time, and your time is valuable. Question 8. List all the blue to red ratios that you could model using 5 counters from the counters to the left. Sketch each model. Okay, so if I'm going just 5 counters, let's choose these 5 first. 1, 2, 3, 4, 5. Well, actually, really quick, let's organize ourselves. Let's just see how many blue we have and how many red we have total. 1, 2, 3, 4 blue. 1, 2, 3, 4 red. Okay, well, we're only allowed to have 5 total. So if I have red on this side, okay, and we'll have to do blue on this side. If I have 1 red, and I've got 5 in total, 1 plus 4 would make 5 in total. If I had 2 red to start, the other part would have to be 3. If I had 3 red, the other part would have to be 2. And if I had 4 red, the other part would have to be 1. So these 4 ratios are the possibles you can have from selecting 5 of these counters. Cool. Okay, moving on. B, name each model using another ratio. Write the ratio as a fraction. You know what? I just realized I didn't completely answer part A all the way. I apologize for that. Part A also wants us to sketch each model. So I'll go ahead and do that. 1, 2, you know what? I'll do blue. 1, 2, 3, 4 to 1 red. Down here on this one, we've got 2 red to 3 blue. Down here, we've got 2 blue to 3 red. And down here, we've got 4 red to 1 blue. Cool. Now for question B, it says, name each model using another ratio. So I could compare this. I can just flip it around, right? I can go red, to blue, and that would be 1 to 4, 2 to 3, 3 to 2, or 4 to 1, right? If you mix up the terms, it is a new fraction. It's just a different way of organizing it. And then it also wants us to write these as a fraction. So this, of course, would be 1 red to 4 blue, 2 to 3. This one's going to be 3 to 2, an improper fraction. This one will be 4 to 1, another improper fraction. Cool. So there you go. Question 8, completely marked. Oops. Clear all that up. And what were we supposed to do? 8 to 13. Okay, so we got a few more questions right here. Let's get to 9. Boom, right here. Use 2 colors of counters. Model the fraction 6/8. Okay, so I'll go 1, 2, 3, 4, 5, 6 to 8. 1, 2, 3, 4, 5, 6, 7, 8. 6 to 8. All right, so there's my model. There's A, done. B, it says write 3 ratios that your counters show. Describe what is being compared in each ratio. Okay, so let's go first purple to blue. So that is 8 to 6. Okay, now let's go blue to purple. That's going to be 6 to 8.